Hi, I'm James Governor, co-founder of Redmonk, the developer-focused industry analyst company. And I'm here to talk to you at Enterprise GraphQL Conf about the new data fabric and what's happening in 2020 and from here on in. So 2020 has been an extremely challenging year for everyone. Very stressful, lots of change, and really frankly, a year that many of us will be happy to see the back of. From an enterprise perspective, it threw up all sorts of challenges in terms of just dealing with change. If we think about the huge challenges when customers aren't able to access your services in the way they hitherto did. Great example for me is curbside. So curbside delivery in the US, it was a nice to have in 2019 and before that. In 2020, it was absolutely essential. If you were a retailer and you couldn't offer a curbside pickup experience, as that was retail, but also, of course, the food industry, then you were in trouble. Now, that's a problem with lots and lots of different facets, obviously. You've got the pickup itself. You want contactless payments, you want contactless pickup, you need to tie into payment systems, you need to tie into your supply chain systems, you need to tie into your warehousing systems. Basically, you need to tie into everything that's happening in store. All sorts of challenges there, and organizations were tasked with this extreme challenge. Now, if you outsourced all your development, if you were only running packaged applications, this was going to be extremely challenging. Organizations that found this easier were those that had developers on staff that could respond to the change. And really, that's what we've been seeing across the industry for many years now. Someone like Target, who used to outsource most of their IT, in fact, they had a 70-30, 70% external and 30% internal, is now more like 80% internal and 20% external. Of course, for them, it's about competition with the likes of Amazon, but certainly that helped them a lot. When they had to turn around, improve, and deliver on the challenges of 2020. So if we think about Marc Andreessen and software is eating the world, this is this idea that he put forward. And we've been seeing that in industry after industry where technology companies are beginning to create significant challenges for incumbents. Now, software is eating the world, but arguably, you could say that managed services are eating the world, because really it's about what can we outsource? And it's not the old style of outsourcing. It's more by task. It's not more by role. There's a different kind of thing going on here where we want to make developers and operators and IT more effective. And the way to do that has been in taking advantage of managed services. Who are using these managed services? Well, it's developers. So GitHub now has a proxy number, shall we say. They say there are 50 million developers worldwide, and that's partly based on how many people are using GitHub, of course. Now, there are replicated accounts, or should I say there are people with more than one account. There are some people who aren't developers that have GitHub accounts. They might be people in design. They might be people in product management. They might be people like me. But overall, we're certainly seeing explosive growth in developer populations worldwide. And I think GitHub's proxy of 50 million is probably pretty reasonable in terms of professional and hobbyist developers in the world in 2020. They're the ones doing the work. They're the ones building the services. They're the ones responding to change. And they're the ones making the organizations they work for more effective. But because of all these managed services, because of the cloud, because of other phenomena like open source, there is just a huge abundance. There is so much choice for developers. So that might be choice of programming languages. They might be choosing something like Rust. They might be choosing something like Kotlin. It might be the old warhorses like Java. Databases. They've got things like MongoDB, Redis for cache. GraphQL is opening up those choices yet again. So graph databases might be part of it. They might be looking at Neo. They might be looking at Neptune. It might be that they are looking at streaming and architectures like Kafka. If they've got all of those choices though, sometimes they're going to make a mess because choice is great, but it creates a cognitive overhead. I know developers that have complained about this, all of these choices, and actually, I'd almost prefer a world where I had fewer choices. Give me a more opinionated stack. Take some of the choices out of my hands because I don't want to be doing the work of sticking all of these systems together with baling wire and chewing gum. Funnily enough, enterprises have some of the same desires and needs because enterprises don't want to give developers so much choice that the enterprise is left trying to understand the choices the developer had made, managing such a plethora of systems and all of the complexity that brings. So there can be some alignment between developer needs and developer experience and what the enterprise wants as well. But of course, that requires that both parties are quite intentional about the choices they make. In data, obviously there are data APIs. There's the world of batch. They might be the traditional batch databases or something like Hadoop. Database choices. We've got the historical proprietary databases. We've still got SQL Server out there. We've still got Oracle. We've still got DB2. DB2 running on the mainframe. They might be using Postgres. Might be using MySQL. We've got the NoSQL stores that I've just mentioned. Events. So we've got Kafka. IoT is generating all of these events. Web services are generating all of this telemetry that we need to access. Might be using the Elk Stack or Splunk for managing your system logs. All of this needs to be managed. All of this is complexity. And we need to be thinking about a fabric approach where all of this can be managed for us so that our developers, operators, and the business can be more productive. There has been a rise and fall and rise again of SQL. So the old world of flat file, IMS, the stuff we used to see on mainframes, obviously was superseded by relational databases. But then relational databases became unpopular in the world of web development until latterly we've seen a rise again. It wasn't enough to just have Memcached and Hadoop and these document data stores. SQL makes sense for such a wide range of applications that Postgres has had a huge renaissance, as has MySQL. Because this complexity is something that we don't always want. Monoliths are and can be productive ways to build applications. Monoliths are a way that we can quickly build something that works. We can evolve it over time. But we don't expect that much change. So how we manage that is something that we really can get a handle on. And it's about managing for stability once we built the initial prototype. And that's how enterprises have built apps. And frankly, that's how the web has done it too. The world of microservices came just because of the sheer speed and developer velocity that organizations like Twitter or Uber were trying to attain. Now, developer velocity is great, but look at the complexity of the Uber microservices graph. Not all organizations are going to want to have to deal with this. But on the other hand, we do want to be breaking things up into components so that we can have that maintainability. And frankly, different parts of the organization are going to want to reuse each other's services. I'm Monk Chips, so co-founder of Redmonk, as I've said, James Governor. What do we do at Redmonk? We are all about developer-led technology adoption. My business partner, Steve, talks about new kingmakers. Basically, that's about the fact that in the world of open source, in the world of social coding, in the world of Stack Overflow, in the world where developers are all learning from each other, where they've got the cloud services that they can access without needing to ask permission, all they need is a credit card, everything has changed. And bottom-up technology adoption has become ever more important. That's the way we look at the world. But of course, it's about bridging bottom-up with top-down because the enterprise still needs to be in control of product management and still needs to have some levels of control in order that the organization can be productive. Programming languages. On the one hand, huge plethora of choices. So you might be developing Android apps and say to yourself, I want to use Kotlin instead of Java. You might be building systems applications using Rust. Go had a huge burst of interest. Every 6 months at Redmonk, we do a programming language rankings, which is based on a scatter plot of behaviors in Stack Overflow and what's happening in GitHub. And what we've seen is there's a lot of froth, there's a lot of noise, but the core languages that are getting the most attention and the most adoption, our model is quite forward-looking, but the most adoption are, number one, JavaScript, and that includes TypeScript now, which is also really crushing it. Second, Python. Python finally overtook Java for the first time in our last rankings. So it goes JavaScript, Python, and Java. Those three languages still remain dominant in terms of application development in the enterprise, web companies, and SaaS companies. So thinking about how you can best serve those developers is important. Let's think a bit about frameworks, because frameworks drive language adoption. Developers are productive with frameworks. Opinionated frameworks that take out some of the configuration and have, frankly, convention over configuration have been very popular. This idea was kind of made popular with, frankly, Ruby on Rails. Ruby was more popular because of Rails. But we've seen that with Node.js in terms of JavaScript at the back end. We've seen that in the world of Java. Certainly Spring Boot is what modern Java is about today. And Django in Python. So frameworks, and there is some standardization. It's one thing to have all of these choices, but they begin over time to stabilize. And certainly in the programming languages, we do see a fair degree of stability. So you don't need to support everything, but it certainly pays to really support developers that want to use those environments and use their modern variants. Because modern developers really want less code and less complexity and less reinvention. They don't want to have to build everything themselves. They don't want to be having to tie together a bunch of services, or rather in their development environments, the developer experience. They don't want that to be a scattered environment that they have to make all of the choices. Where they do want to make the choices is in a rich palette of services that they can consume in building composite applications. They want everything to be self-service. They want it to be managed. And they don't want to be handing it off to someone that's going to be hassling them. They want it to be a fully managed kind of experience. I do want to say that open source still matters. Of course, we don't demand that everything is open source, but what we've seen time and time again is that enterprises and developers, they have a comfort factor when they know that code is open source. We've seen that most recently with Kubernetes. I think Kubernetes is really interesting because it's become the infrastructure of choice for enterprises that are looking for portability. But even there, we want the portability, but we also want managed services. And you've seen the rise of things like AKS, EKS, and so on, where frankly we want that to be a managed environment too, but a managed environment for infrastructure services. Talking of infrastructure, it used to be we had to do everything ourselves. We built our own networks, we bought our own storage, we built our own data centers, we made our own compute choices. It was a build your own, a roll your own model for IT management. That's been superseded now by the cloud. The cloud changed everything. Cloud said, look, we're going to take compute and just provide it for you as a service. We're going to take storage and do the same thing, even messaging. And over time, there have been more and more services and higher level services that the cloud has begun to manage for and on behalf of the user. Amazon took that a stage further with serverless, where you could have these managed services which would scale to zero, which the user would only pay for when they were using it, and as soon as they were no longer using it, they would no longer have to do that. It's a new economic model. So you've got startups that are saying to themselves, unless the user is actually accessing the service at that time, we don't need to worry about it, we don't need to manage it, and frankly, we don't need to pay for it. Serverless has been a hugely attractive model that Amazon pioneered with Amazon Lambda. Now, The people that like Amazon Lambda, and that's interesting because they're both enterprise developers, a lot of what you might call laggards have latched onto this model because they don't want to be dealing with all that complexity that you get with something like Kubernetes. But also with like hipster developers that are building from the ground up on new stacks that, as I say, they're about like, we want a different way of developing, which is completely managed by Amazon. So it's meeting both sides where they are. And I think that's a really interesting part of the serverless phenomenon. But they've said, hang on, we want some APIs and services from outside. We don't want everything to be the Amazon service. So we might be using Algolia for text search. We might be using Auth0 or Okta for identity management. We do want some choices. Now, those developers are generally saying, we're going to be building rich front ends, React or mobile, calling these services, these rich managed services at the back end. And one of the ways that we begin to talk about this is client-serverless. So it's sort of pun on the old client-server world, two-tier application model. Rich clients calling these services at the back end. Client-serverless, you're going to be hearing a lot more about that over the next few years. And that's how a lot of modern developers want to work. Now, another way of thinking about that is Smokestack. So Mark Hinkle said, hang on a second, James, it's not all this two-tier world. We want serviceful applications. Yes, we want them to be mashable, open, composable, and composite with a K because they're Kubernetes people, and event-driven. This world of event-driven and reactive programming is ever more important as applications span organizational boundaries. As they span applications, and thinking about events is a great way of thinking about the future of software delivery and development. But what about this software delivery and development? I think that iPhone and smartphones tells us something really interesting. So if you think about iPhones and all of the things they've swallowed our car keys, they've swallowed our wallet, they've swallowed our calendar, they've swallowed our spirit levels, they're swallowing our healthcare devices. They're taking more and more stuff, virtualizing it and putting it, frankly, into a small form factor that's really easy to use with intuitive services. The same thing is happening in the cloud. And I've been thinking about this. So it's one thing to collapse those things into a phone in the way that Apple did. But I think the cloud is collapsing jobs, taking jobs and virtualizing them. And that's really, actually, I think, foundational as changing how IT works today. So Clayton Christensen put forward a model called jobs to be done. And he meant it in terms of, look, if you want to sell something to someone, make it easier for them. Make their job easier, and they will buy that service. Take something that's an annoyance, smooth that surface off, and that will be adopted by people. That's what the cloud is doing. It is indeed collapsing jobs and putting them into automated services in the cloud. Even something like DBAs. If we think about DBAs, that was a job for many, many people, still is. But what we've seen is enterprise organizations we were surprised. We saw a financial services company came to us and said, we're actually going to get rid of our DBAs, move all of our database into the cloud. We will invest in data engineers, but that role that we used to have is frankly going away. So things do go away, but as I say, new roles are created. So it might be machine learning specialists or analytics, people that are really great at visual storytelling. So one job goes away, but new jobs are created. We see a rise of specialization and a fall, and then a rise again of specialization. As I say, in Kubernetes, we can't have every developer needing to understand every internal of that stack. We can't have every developer in our organization understanding Helm charts, understanding YAML. Some of them should just be building business logic. That's why we're seeing the creation of more PaaS-like experiences, again, across containers, whether that be Google Cloud Run, whether that be the products and platforms being delivered from the likes of VMware and Red Hat and Google today. Because platform operations is not the same as application development. Nobody can afford to invest above market rate for developers in the way that like a Netflix can, or those highly capitalized startups that we may be competing with in future. We need to have a platform team creating rich services, curating those services that are then consumed and used by application developers. Both sides do DevOps. Both sides need to understand how the application will be managed and think about observability, but they have different perspectives on that. And for me, I think that's one of the reasons why GraphQL is so interesting, because it begins to create a separation of concerns. Who are building the APIs and who are consuming the APIs are a different set of folks. GraphQL that offers that performance. So if you think about it, we don't need to be continually hitting the database. We want high performance, developers clearly do, and so do end users, but also predictability. We want to know what the response when we call the database is going to be. We don't want to throw up errors. We do want to make things easy for developers. Portability, GraphQL is of course a standard, but we by exposing services with GraphQL, we can make them accessible to, as I say, a wide range of programming languages. It might be those Spring developers. It might be those Django developers. Control. So we've got control, we've got the database, the data source managed as a separate thing, and then of course that maintainability. So we can do a schema migration. We want that to be separate from the developer experience. And I think it's that separation of concerns is one of the reasons that I find GraphQL so fascinating. And developers love GraphQL. That's the thing. We saw it sort of once that it had become a technology that was accessible to them. Facebook started out, sort of GitHub began to make all of its API services available as via GraphQL. We knew that something was afoot because we saw the same model in what was historically that world of XML and the web services stack, which was really sort of pushed aside by REST because developers preferred it. We're beginning to see developers' preference for those GraphQL-style APIs and that modern web development experience. And so we need to think, how do we take all of our old world applications, all of the application estate we have, all of the data estate and the data fabric that sits on the enterprise estate and in the cloud that the enterprise is using, and make that accessible as a set of services for developers. So hybrid and multi-cloud convergence. It's one thing to say developers using only higher order services from these from the cloud, and that's how I think, frankly, about hybrid cloud. It is about these services, but also multi-cloud as well. Is very much, hang on, I'm going to be using one managed service in one place. It might be I want some data management in something like BigQuery, and I'm choosing Google for that. But then I'm frankly running a lot of other applications in AWS. But what were sort of different things seem to be converging. We want a managed platform for hybrid and multi-cloud, and that's where the industry is currently heading. So if we look at OpenShift from Red Hat, if we look at Tanzu from VMware, if we look at Anthos from Google Cloud Platform, we're beginning to see these munged, schmooshed platforms for hybrid and multi-cloud, and enterprises can get their head around that. That's the kind of thing they want to consume. So we've got the traditional back-end services and applications, SAP, Workday, Oracle, Salesforce, and so on. Then you've got the cloud vendors providing managed services and infrastructure services, and the companies that are just providing higher level services. The folks I've mentioned, Algolia, Auth0, Stripe for payments. Nobody should be building their own payment systems. That seems absurd in 2020. Stripe is there, they are excellent at it, they provide great docs, great APIs, and that's why developers choose them, and that's why it's beginning to make an impact in the enterprise as well as web companies. Might be Cloudinary for image resizing, just make things easy. But what we need to do is pull all of this stuff together. Last week, we saw Twilio acquire Segment. So Twilio, which came out of the world of sort of SMS and messaging, frankly, just so many hackathons where a developer wanted to have a different interface. Hey, I know, we'll use a mobile phone, we'll use Twilio to deliver an SMS to that phone. They're frankly a huge business now, and they bought Segment to take customer data with that same API-driven approach. And increasingly, that's the way the world is moving. Twilio and Segment are going to be competing with the likes of Salesforce, very much on the basis of APIs that developers like and want to use. Managed services, we've seen in the world of data warehousing is not something that's easy to manage yourself. Snowflake did a brilliant job of creating a great managed experience that's got a good developer and practitioner experience and is fully managed, runs on Amazon Web Services. And that's one reason why their IPO, which is again very recently, was so explosive. Taking that old world model, taking it into the cloud as a managed service with good developer experience, that's increasingly where we want to go today so that we can be effective in 2020 and beyond. So what's missing? If we're thinking about GraphQL, if we're thinking about, I mentioned a data fabric, but who's going to stitch it all together? We've still got different choices. That's true in the cloud. It's certainly true of on-prem. We're looking for partners that are going to provide integration for us and make it easy to do things. It might be something as simple as taking a Postgres schema and turning it into a GraphQL API, or a MySQL schema and turning it into a GraphQL API. But there are other things. You might be wanting portability. So if you put everything in Amazon, the egress costs are likely to kill you. How are you going to manage persistence and state? If everything is stateless, what about if we have an application that needs to manage state because it's a multi-step, multi-party workflow? Who's going to help us manage that? Composite management layers across that. Single models for authorization or authentication across these data services. Because frankly, application development is always data-driven. And so thinking about this data-driven data federation, who's going to provide an experience that makes it easy for us to as platform owners, make our developers productive? That's the big question. And that's a question I believe that Hasura is trying to answer. So enjoy the conference. I hope you learn a lot. I hope you enjoy it. And I look forward to seeing the applications that you build in the new data fabric. Thanks very much. It's James Governor at Redmonk.
Data fabric, that's a term that's new to me, but it's one that I find really compelling. It was in the title. It sort of felt like it was encapsulated in the entirety of the talk, but that was 27 minutes. I'm wondering if you had to summarize a data fabric in the most pithy way possible, sort of what that would be to you.
Yeah, I think from my perspective, it's pretty simple. I talked a lot about the fact that we've got a lot of data store and database choices. Also, where the data is going to reside. And so just thinking about a layer, a platform that will begin to provide access, managed access across a number of different data stores and streams and so on. That's really where I was going with this, that, we just see so much choice. I mean, you could be just an Amazon Web Services customer and frankly, you're still going, wait, how do I stitch all of this together? So it's like, what is the platform for making me more productive when my applications are composed of a range of different APIs and databases.
Understood. So that sort of story you were telling around, I think the words you used were hybrid and multi-cloud convergence, and the emergence of platform ops as a function or a responsibility. That's sort of the notion of who it is who's looking after this broader data fabric.
Yeah, I think that's right. We've been through a period where I just think there's been too much expectation that everyone can do everything. And it's too much. It's too complicated, and it's not necessarily helping either the developer or the operator. And so I think if we think about developers currently have cognitive overheads in terms of the number of choices they need to make, and then we go and say, oh, and by the way, you need to do everything in terms of managing the application and so on. Then you've got platform teams saying, wait, if we give developers too much choice, we have a technical debt overhead. And so I think it's really about taking a step back and saying there are some people, whose job it is to build apps, and there are others whose job it is to help them be effective by, providing platforms with rich services that make them productive. So yeah, I think that we've been through a period, and especially in the Kubernetes world. Look, the premium required to have staffs of people that understand all of that stuff is just way too high. let developers do their work, which is software development, and let the infrastructure people really focus on that.
Okay, that totally, as someone who began their career as a DBA and then realized that they actually just liked talking about the software other people built for a living than trying to build it myself, like that resonates with me, that notion. And it leads into the other point you made that I think is a really interesting tension that we see, that I think all of us who are on the call probably see, which is the balance between velocity and complexity. And you spoke about that. I'd love for you to expound on that a little bit more, because Tom and I spoke at the end of his talk about sort of an iterative or an incremental approach to adopting something like GraphQL. And I find that incrementalism is often caught in the balance between velocity and complexity. I'd love to just hear your thoughts on that dichotomy almost.
Great. Yeah, I think it's a really a nice articulation. And I think it goes further because, I think that it's complexity, reliability, and then, quite frankly, or complexity and velocity, but also reliability. So I think that if you're a Silicon Valley startup, everything is about developer velocity. Oh, I need to onboard new employees because I'm growing so fast. That's not necessarily what the world looks like if you're a pharma company in Germany, right? Or you're a bank or something. You may have compliance requirements that you need to deal with. Complexity definitely creates management overheads. And so managing that, it's quite interesting because if we take a step back, how were we developing 10 years ago? We would build a monolith, and we would understand that environment. It would be well bounded. We would move forward, and over time, we would have to refactor that and think about, okay, perhaps should we be using a different programming language? Should we be using a different runtime for this? If you think about like Twitter ending up using Kafka, the question about what you should build, I think at that point was all about that velocity statement. I think what's quite interesting is the degree to which the industry has currently gone through a period of baking in complexity from day one. With like, oh, you should use microservices, and that's fine, but it's really not for everybody. I mean, for some people, it's like, wait, maybe you should be building a monolith. So I do think that question about reliability, about velocity, and about complexity is one that everyone needs to be. The most important thing is product market fit, and that's true whether you're a startup or whether you're an enterprise. Don't overcomplicate things too soon. And I think that's why you want to take advantage of platforms that will abstract some of that complexity for you.
Excellent. That's helpful. It resonates, and personally, it actually gives me quite a bit to chew on and ponder as well. As you mentioned in the talk, the Twitter handle is @MonkChips. The organization is Redmonk. James, mate, thanks as always for your time and for sharing your knowledge with us.
Thanks. Can't wait to see you in person sometime soon.
Indeed.